Welcome to the second video on data types, declaration and operators. Basically, this is the fourth video of the entire series on basic C programming. But since data types, declaration and operators is a large area to cover, so for better understanding and to keep that interest intact in you, I have divided into many parts. So this video marks the second part of data types, declaration and operators. Now coming to the other aspect of this video. In the previous video we have seen about data types, different types of data types and their corresponding size and some specifiers. In the previous video also we have seen that data types are three types. One is the primitive data type, two is the derived data type, and three is the user defined data type. Now the last two, that is the user defined data type and derived data type, are not being discussed in this particular module. Those will be discussed as different topics of C programming. When we will go dig deeper into the aspects of C programming, we will understand that what are those data types, what are their attributes, etc., etc. But when somebody talks about data types, generally it means primitive data types. But it is wrong to say that the other things like user defined and derived data types do not fall under the category of data types. No, that is wrong. Generally data type means primitive data types. So we will actually discuss about the primitive data types in this particular video. We have seen that there are different primitive data types. We have seen some aspects of them in the previous video, and I've told you that you will learn about them in the later videos. So in this particular video you are going to learn about the primitive data types and another aspect of computing world that is known as ASCII values. Along with the primitive data types and their details, we are going to learn about ASCII values. Next. So in this particular slide you have seen in the previous video. What is the importance of this slide? We are going to understand it. So let's go to the next slide. We are going to study integer, character, float and double, and we are going to come back over here and we are going to see some of the things that are present over here. Okay, we are going to cross check them, why they are like this. Okay, now integers. Now what are integers? In mathematics many of us have studied integers. While we have studied set theory, we have learned about integers. Integers are those real numbers which do not have any fractional parts. That means, for example, 2 is an integer, but 2.15 is not an integer because 2 doesn't have any decimal part, any fractional part attached with it. So it is an integer. But 2.15 has a decimal 0.15 added with it. So it is not going to be considered as an integer. So those numbers which do not contain any decimal part, as a matter of fact, 2.0 is not an integer. 2, only 2 is an integer. We're going to it will become clear when we discuss about floating point numbers. But for now you try to understand that any number which do not have any decimal point attached with it is an integer. Now in the previous slide we have seen that for int, that is integer, the size is 2 or 4 bytes. It depends on the computer. We have discussed it in the previous videos. And accordingly we are given two sizes, two ranges of values, that is for 2 bytes. The computer, the values that can be stored ranges from minus 32,768 to 32,767. And for 4 byte it is minus 2147,483,648 to positive 2147,483,647. So how do you get these values? How do you calculate these ranges? The way to calculate the ranges are given in the next part. That is, for to calculate the size, or to calculate the range, to be specific, to calculate the range of values that integer can hold, we use the formula minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1, where n is the number of bits. Now for 2 byte machine, you see the value 32,000, that thing. See, now observe that 1 byte comprises of 8 bits. So 2 byte will comprise of 16 bits. So if there are 16 bits, then according to the formula, it stands out to be minus 2 to the power 15, which is equals to 32,768. You can cross check it. 2 plus 2 to the power 15 minus 1. That is also the same thing. You can understand it, isn't it? It is understood, isn't it? So now for 32-bit machine, that is 4 byte machine, for 4 byte, that is one word occupies for one word space, for one word, that is 4 byte space, it will be 32 bits, because 1 byte means 8 bits, so 4 into 8 will make up 32 bits. So for 32 bits, it ranges for the value that the integer can hold is from minus 2 to the power 31 to 2 to the power 31 minus 1. This is very interesting. If you can understand these things, it is very interesting. Now why it is like this? Suppose, see, for 1 byte there are 8 bits, isn't it? For 1 byte there are 8 bits. It is all about probability, it is all about permutation and combination. For 1 byte there are 8 bits. Okay, now for 16 bits, that is, you have 2 bytes. Now numbers in computer are represented by ones and zeros, so each bit can hold either 1 or 0. So each bit can hold two values, either of the two values. So by the theory of probability, it comes out to be that the range of values is from minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. So this is from the not probability, from permutation and combination concept, it comes out to be like this. So let's go to the next part, float. Now in integers, we have seen that the drawback of integer is it cannot hold any decimal number, not even 2.0. For that you have to assign 2, only 2 for it. But if you want to assign 2.0 to something, then float and double, these two are the places where you should keep the values. Okay, so basically the numbers, all real numbers, are termed as floating point numbers in case of computer science. Alright, in case of computer science, the real numbers, including the decimal ones, fractional, real means that there can be fractional parts as well, are represented by floating point numbers. and float is one part of the floating point numbers with memory allocation size of 4 byte, and double is the other wing which has a memory allocation space of 8 bytes if you observe it properly. For double it is 8 bytes, and for float it is 4 bytes. That is why the name, you see, for float it is 4, and for double it is double of 4, that is 8 bytes. That is why the name double has been assigned. Alright, so any real number that is 224.45678 is a floating point number. It can be held in float or double. It depends. Alright, don't unnecessarily use double the number where the maximum number can be held within float, because you have to know about memory. You have to be very um, calculative when you are thinking about memory consumption of a program. The less memory you make the program to consume, the better the programmer you are. Your program should consume the least memory. Alright, you should consume least memory while writing a code. Then only you are a good programmer. Now see, in case of the ranges of values of float and double, you see there is a term 3.4e minus 38, 3.4e plus 38. So what are these things? So this is e notation, it is known as exponential notation. So suppose there is a number 123.45. In this slide we have an example 123.45. So it can be expressed as 1.2345e plus 2. What does this mean? It means that 1.2345 into 10 to the power 2 e, capital E, means into 10 to the power. Alright, into 10 to the power. So it comes out to be 123.45. So you can understand that 3.4 e minus 38 means 3.4 into 10 to the power minus 38. There is a range of values that it can hold, that float can hold. Alright, I hope it is clear. So the next thing is character. Character means any value that can be a digit, alphabet, a special character, anything, but it has to be a single character. Alright, can be held using the character data type. Now the memory space that is allowed for a character is 1 byte. Alright, for it is 1 byte, and each character has a integer corresponding value in the memory, in which is known as the ASCII values. We are going to learn about this in the next slide. So the thing that you need to note over here is that suppose you give a number 12. 12 itself is a number for integer, isn't it? But for character, 12 is actually two different characters, 1 and 2. Alright, 12 doesn't comprise of any one character. 12 is actually two characters. One character is 1, another character is 2. So character can hold only one character at a time. Now, the ASCII values. ASCII stands for American Standard Code for Information Interchange. Alright, American Standard Code for Information Interchange. For every character that we have in our keyboard, or that we don't have in our keyboard, there are decimal values, hexadecimal values, and octal corresponding values for each of them. Alright, that means, for example, you can see the 65th decimal that you have, the 65, that represents capital A. That means if you want to represent capital A in terms of integers or decimals, then the value will be 65. Likewise, there, for every character in keyboard, you will be able to find out the American Standard Code for Information Interchange, or ASCII value. Now let us write a code to know the um, character, right, or to know the ASCII value of a particular character. So as you know, we are going to use the VI editor. For that we need to fire up the browsers. That is what we are doing. And then we need to go to the online Linux terminal. The first link of tutorials point. And here we are going to use VI editor. VI, suppose 2ASCII.c. 2ASCII is the name of my code and .c is the extension, and I am opening it in VI editor. Now I have to press I to go into insert mode. I have pressed I and I am in the insert mode. And now I will press include the stdio.h header file, stdio.h header file. Not only that, I have missed something, that is a hashtag. Okay, no functions are required here, so I will write int main. Alright, now one thing that you should understand here is that to hold a character value, you use the keyword char. You give a name to the character, which here in this case I am giving ch, and I assign a character within single quotes. In case of character, you need to assign the value in single quotes. Suppose it is capital A. For capital A, we have seen the value. Here we are going to print the value of A. What value of A? The decimal value of A, which is the ASCII value. So for decimal, we use the specifier %d. These things will be taught later on, but for now on, if you want, for now, just remember, if you want to represent a number, if you want to print a number, alright, of a data type, of a data, for example, here I have used ch. I want to print the value of ch. Now ch is a character. Ch is a character. Now what is the ASCII value? ASCII value is the decimal equivalent of that character. Now for this character, the equivalent decimal will be printed over here. Okay, we have seen that we print messages inside printf functions, etc., etc., but we will know about printf function just after this module ends. Alright, so this marks the end of my program. Alright, so I'm going to return 0. Now see, here I have a character cha. I'm going to see what is the ASCII value of character ch. So let us print a message like this. Alright, let us print a message like this. Say ASCII value of, for character we use %c, is %d. Now for ch, comma ch. Now what happens is that this ch, the value that is there in the ch, will be replaced in this position, and this ch will be replaced in this position. Okay, so let us run. We will know about the details, alright? Don't think that this is printf function, you know everything about printf function. Even I know that I have told something that is not exactly right over here, but for your better understanding, in this case I have told that. When I will discuss about printf function, I will tell you about these things. So let us exit by pressing :wq, and now we are going to use gcc to ASCII .c. Alright, so it has been compiled. Now ./a.out. ASCII value of A, capital A, is 65. Let us verify it. What is the ASCII value of A? The ASCII value of capital A is 65. See, it is 65. Suppose we want to find out the ASCII value of a space. Now find out space over here. Where is space? Where is space? Where is space? Is 32. So in place of the character, we open the program in VI to ASCII VI, and we replace A with a space. Okay, with a space. And now let us see what is the ASCII value of C. We have to follow the same procedure. To ASCII ./a.out. 32 of space is 32. You saw it. See, 32. This is the message. So this is how you actually write a program to find out the ASCII value of a particular character. So this is actually what we have learned. So it was the last slide basically. Anyways, so what we have learned in this particular video is what are integers and how to calculate the range of values that integer data type can hold for different bit machines. We have learned about float. We have learned about capital E formats. We have learned the difference between float and double, though both are the same things, but it differs in size and memory allocation and the range of values that it can hold. We have learned about characters, and we have learned about ASCII. Now in case of characters, you see there is a line. With most compilers, a character type permits value of 0 to 255. Alright, what does this mean? See, character has got 1 byte, that means 2 to the power 8 values it can hold. Alright, 2 to the power 8 means it is 256, something like that, if you calculate it. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64, 64 2s are 128, 128 2s are is 256. So 2 to the power 8 is 256. So 256 number of characters can be hold, different types of characters can be hold in that particular in characters data type. Okay, now that is where from that place the concept of ASCIIs have been developed, because each character can be represented by a 3-digit number. So you can represent total of 256 numbers, 0 included. Okay, 0 to 255 is actually 256 different numbers, different codes. Alright, for in case of capital A it is 65, so it is 065 basically, 065. Understood? So this is how you actually this is how the concept of ASCII came into play. Alright, to make the use of characters more feasible in computer programming. Now as you can understand that in every data types we are requiring numbers, isn't it? Even characters, capital A is also a number. You can see for capital A it is actually represented by 65 in ASCII values. So everything in computer science is actually numbers, nothing else. So I hope you understand this thing and you enjoyed it. In the next videos we will learn about declaring these things and these data types and do operations on it, and some typecastings needs to be taught, that will be taught later on. So I hope you liked the video, and please stay tuned for the next videos. Till then, thank you everyone, and stay tuned.